Welcome to this video on introducing proportional relationships. Students will develop the idea of a proportional relationship out of grade 6 idea of equivalent ratio. Students will recognize when a relationship is or is not proportional and represent proportional relationships with tables, equations, and graphs. Here are the essential vocabulary words that will be introduced throughout the unit. Constant proportionality, equivalent ratios, origin, and proportional relationships. Students will begin their learning about proportional relationships with tables. For an example, this table is about a recipe, and this recipe says for every 5 cups of grape juice, mix in 2 cups of peach juice. We can make different sized batches of this recipe that will taste the same. The amount of grape juice and peach juice in each of these batches form equivalent ratios. In a table of equivalent ratios, a multiplicative relationship between the pair of rows is given by a scale factor. The relationship between the quantities of grape juice and peach juice is a proportional relationship. In a table of a proportional relationship, there is always some number that you can multiply by the number in the first column to get to the number in the second column for any row. This number is called the constant of proportionality. In this example, the constant of proportionality is 0.4, or 4/10. There are 4/10 of a cup of peach juice for every 1 cup of grape juice. Students will learn to write equations that represent proportional relationships. For example, in this table, if each square foot of carpet costs $1.50, then the cost of the carpet is proportional to the number of square feet. The constant of proportionality in this situation is 1.5. We can multiply by the constant of proportionality to find the cost of a specific number of square feet of carpet. We can represent this relationship with the equation C equals 1.5F, where F represents the number of square feet and C represents the cost in dollars. Remember that the cost of carpeting is always the number of square feet of carpeting times $1.50 per square foot. This equation is just stating that relationship with symbols. The equation for any proportional relationship looks like y equals kx, where x and y represent related quantities and k is the constant of proportionality. As students move through the unit, they will start looking at situations where they'll be able to compare proportional relationships versus non-proportional relationships. Students will be able to easily work with common context associated with proportional relationships, such as constant speed, unit pricing, and measurement conversion, and be able to determine whether a relationship is proportional or not looking at tables. Students will also be able to look at equations to determine if their relationships are proportional or non-proportional. Students will also work with graphs that represent proportional relationships. For example, here's a graph that represents a relationship between the amount of square feet of carpet purchased and the cost in dollars. Each square foot of carpet costs $1.50. The point 1015 on the graph tells us that 10 square feet of carpet cost $15. Notice that the points on the graph are arranged in a straight line. If you buy 0 square feet of carpet, it will cost you $0. Graphs of proportional relationships are always part of straight lines, including the point 0, 0, which is also called the origin. Students will be able to also look at representing proportional and non-proportional relationships with graphs. Here are 2 graphs. One graph represents a proportional relationship as it has a straight line that goes through the origin 0, 0. The second graph has a straight line. That is a non-proportional relationship as it does not go through the origin, 0, 0.